In this problem, you've been asked to reduce this pretty awful looking fraction here to lowest terms. Let's just dig in and take a look then. So it might be tempting to just start canceling things right away, like you might look at the t here and think you can cancel this t right here, so maybe this t will become a 1 and this t here will become just a t, and same with the s's here. So would it be true then that if I cancel this t here and that, one of those t's and this s and one of those s's here, would I get something like 1 minus 1 on the top over t minus s, s, but 1 minus 1 is equal to 0 over t minus s, so it's all equal to 0. Would that be the solution there? The answer to that question is no, it absolutely would not be the solution. And one of the premises of algebra here is when you start canceling these fractions here, you can't go canceling across a sign like this. So the s and t are sort of joined here. You can think of these plus and minus signs as a chain. You can't go canceling across the chain. Same with the minus sign right here. So this is just all plain wrong. Let's just start again here and see if we can get it right this time. So s minus t over t squared minus s squared. The problem is asking you to simplify this. So what we can do then is we just have to start recognizing some patterns. A lot of these simplifications and things like that are about recognizing patterns. And I see a difference of 2 squares in the bottom of this fraction here. So let's see if we can rewrite that. There really isn't much I can do with this numerator at all, except for just write it as an s minus t right there. And if I wanted to factor this here, well, the difference of 2 squares, this is going to be t plus s times the quantity t minus s. And if you sort of don't believe that or forgot or something, you could definitely multiply this out. And we could just do a quick check on this if you want right here. If I use the FOIL method, t times t is just t squared, and then t minus s is minus ts, and s times t is plus st, and then s times minus s is minus s squared. Minus s squared, I can barely fit it on. So you see these inner terms cancel here, the minus ts and the plus st, they cancel there. I'm just left with t squared minus s squared, which is my original denominator over here. So now if you look at it sort of carefully, you basically have it down to some pretty raw terms here. There isn't much you can do with the s minus t. I mentioned that, the t plus s or the s minus t. But if you look very carefully here at this t minus s term right here, this one right here, it is sort of related to this one right here because they're sort of negatives of each other here. So I look at this s minus t and t minus s, how are they sort of related here? Well, if I look at this t minus s here, suppose I factored a minus 1 out of this t minus s term right here, what I'd get is I get minus t plus s, or if I rearrange the terms here, I'd get s minus t. So you see, the term here, t minus s, is exactly equal to, right here, let me just write this out here, the term t minus s is exactly equal to the negative of s minus t. So again, just some of these patterns you have to start learning how to recognize if you're going to get these things sort of simplified properly. Let's plug that in now. Let's go back to our original equality here and say, okay, all this is equal to s minus t. Again, there's that numerator I can't do much with. Here's a t plus s here, and now as we stated here, this t minus s here is, let's be careful how we write this here. I'll put a big square bracket here, minus s minus t. Now the reason why I said we need to be careful the way we write it there is because we didn't want to make it look like t plus s minus t. Remember, it's a big product in the bottom right here. Let's just keep working on it now. This negative sign here is almost like a negative 1. Let's just pull it all the way out in the front here. So I still have the s minus t in the front. And if I pull the minus 1 out in the front here, and I put a big square bracket to denote my whole denominator now, this will be a t plus s. And now what do I have here? S minus t. So now you can see some big time cancellation which is going to happen here. This s minus t in the top is going to cancel that s minus t right there. And so it's going to be gone. Now I can go ahead and move the minus 1 up to the top if I want here. So I'll just have sort of a minus 1 over t plus s. That's your final answer here. So if you wanted to put it all together, then the original fraction here, s minus t over t squared minus s squared, is equal to negative 1 over t plus s. There you go.